This lesson focuses on the authorization rules to help reason through your contract models. By understanding DAML's authorization rules, you will be able to construct your contracts in a way that avoids authorization errors during runtime and, more importantly, prevents the execution of malicious transactions. You learned that a transaction is a list of ledger actions, and an exercise action exercises a choice on a contract, resulting in a list of sub-actions called the consequences. Each action has a set of required authorizers, the parties that must authorize that action. The required authorizers of an exercise action are the controllers on the corresponding choice. Remember that the built-in archive is just a shorthand for exercising the implicit archive choice with the signatories as controllers. The required authorizers of a create action are the signatories of the contract. The required authorizers of a fetch action, which also includes the fetch by key statement, are any one of the stakeholders of the contract being fetched. The required authorizers of lookup by key are all the key maintainers for the key you are attempting to look up. And each action has a set of authorizers, the parties that did authorize the action. The root action or actions are authorized by all of the submitting parties. Every transaction starts with a command or a list of commands sent to the ledger from a client application. These commands are authorized by the submitting party, whose credentials are included with the submit. The consequences of an exercise action, which are the actions listed in a body of a choice, do not automatically inherit the authorization of the submitter. The consequences of an exercise action are authorized by the controllers of the choice, plus the signatories of the contract on which the action was taken. Now let's see what that means in a transaction tree. Here is a transaction tree with its list of ledger actions. The transaction tree was generated when the party Bob exercised a send IOU choice on a payment channel contract. This ledger action has two consequences, fetch and exercise. Among those two, the exercise action has a consequence of creating a new IOU contract. Let's take a look at the number 42 as an example. The required authorizers of exercising mutual transfer are the controllers of the choice, Bob and Charlie. With this in mind, let's check out the code that generated this transaction tree. There are two templates, IOU and payment channel. Once an IOU contract is created by an issuer and a sending party, a receiving party can create a payment channel contract to allow the sender to send the IOU to the receiving party. The sender can exercise a send IOU choice by passing a contract ID of an IOU contract as an input. Within the body of the send IOU choice, the mutual transfer choice is exercised on the input, reassigning the receiving party to be the new owner. The mutual transfer choice creates a new IOU contract with the new owner as the owner. Send IOU choice is a non-consuming choice, allowing the sending party to send IOUs to a receiver multiple times. Let's take a look at the test script. Parties Alice, Bob, and Charlie are allocated. Alice creates a new IOU contract, setting herself as both issuer and owner. Bob creates a payment channel contract to allow Alice to send him IOUs. Charlie also creates a payment channel contract to allow Bob to send him IOUs. Finally, Alice sends her IOU to Bob, and Bob sends it to Charlie. Now let's analyze the last submit expression where Bob sends the IOU to Charlie in terms of the authorization rule. Let's revisit the transaction tree from the script where Bob sends an IOU to Charlie using a send IOU contract. Bob submits the transaction, so he is the authorizer on the root action, which is to exercise send IOU on a payment channel contract with Bob as sender and Charlie as receiver. Since the controller of that choice is the sender, Bob is the required authorizer. At number 4.1 and number 4.2, the consequences of the send IOU action are authorized by its controller, Bob, as well as signatories of the payment channel contract on which the send IOU choice was exercised. That's Charlie in this case, so the two consequences are authorized by both Bob and Charlie. Ignore the fetch action for now and focus on number 4.2, which shows the exercise action. Bob and Charlie exercise mutual transfer with Charlie as new owner on the IOU contract, which has Alice as the issuer and Bob as the current owner. The required authorizers of exercising mutual transfer are the owner, Bob, and the new owner, Charlie. Finally, number 4.3 shows that the consequences of exercising mutual transfer are authorized by the controllers, Bob and Charlie, as well as the signatories of the IOU contract, Alice and Bob. There's a single action on the consequences, which is the create action. The creation of an IOU with issuer Alice and owner Charlie has the required authorizers Alice and Charlie. Finally, let's delve into the topic of how a party's authority is not transferred transitively, which will enhance your understanding of the missing authorization error. Here is a simple template non-transitive, which takes sig and obs. The signatory is sig and the observer is obs. Sig can exercise swap sig and obs choice, which is a consuming choice that creates a new non-transitive contract by switching sig and obs. Obs can exercise swap another, which takes another non-transitive contract as an argument to exercise swap sig and obs on it. Let's try exercising swap sig and obs. The parties Alice and Bob are allocated, and Alice creates a non-transitive contract with Alice as sig and Bob as obs. Alice exercises swap sig and obs on the contract and runs into a missing authorization error, which says that Bob's authorization is missing. Let's walk through the transaction tree to analyze why this happened. Under the committed transactions, the root action number 00 for creating a new non-transitive contract is authorized by the submitting party, Alice. The failed exercise indicates that exercising the swap sig and obs choice on the contract created from the root action number 00 failed. Under the subtransactions at number 0, Alice, the controller, is the required authorizer of exercising the swap sig and obs choice on the non-transitive contract. Since it is the root action, it is authorized by the submitter, Alice, and the consequence of exercising swap sig and obs is the create action at number 1. Based on the authorization rule, the consequence is authorized by the controller of the choice and the signatory of the contract that the choice is exercised on. In this case, the controller of the swap sig and obs choice is Alice, and the signatory of the non-transitive contract that swap sig and obs choice is exercised on is also Alice. However, number 1 indicates that Bob is the required authorizer of the create action. Bob should have been one of the parties that authorized the consequences of exercising swap sig and obs, but they were only authorized by Alice. This explains the error message on the top, where it says number 1, create of non-transitive failed due to a missing authorization from Bob. Let's try exercising swap another. Have Alice create another non-transitive contract NT2. Again, Alice is sig and Bob is obs, just like NT1. At the end of the test script, have Bob exercise swap another choice on NT1 by passing in NT2 as the argument of the choice. Under the committed transactions, the create actions number 00 and number 10 are both authorized by the submitting party Alice. The action number 00 represents the creation of NT1, and number 10 represents the creation of NT2. The failed exercise indicates that exercising Swapsagendob's choice on the NT2 contract created from the root action number 10 failed. Under the subtransactions, at number 0, Bob is the required authorizer of exercising exercise swap another. Since it is the root action, it is authorized by the submitting party Bob. The consequences of exercising exercise swap another are authorized by the controller of the choice, Bob, and the signatory of the contract that exercise swap another is exercised on, which is Alice. At number 1, in fact, the required authorizer of exercising Swapsagendobs is Alice, and the consequence of this action is authorized by the controller of the choice Swapsagendobs, which is Alice, and the signatory of the contract that the choice is exercised on, which again is Alice. However, number 2 indicates that the required authorizer of the create action is Bob. This explains the error message on the top, where it says to create of non-transitive failed due to a missing authorization from Bob. This example illustrates that authorization in DAML does not propagate down the transaction tree. In the last submit expression, even though the root action of exercising exercise swap another is authorized by Bob, Bob's authorization is missing for the last create action. A transaction is a list of ledger actions, and an exercise action may result in a list of sub-actions called the consequences. Each action has a set of required authorizers, the parties that must authorize that action, and a set of authorizers, the parties that did authorize the action. Remember that a party's authority is not transferred down the transaction tree to avoid missing authorization errors.